Welcome to this Einthoff presentation about our unique M6 Plus instrument, which allows true three-dimensional characterization of a wide range of samples. The M6 Plus takes our state-of-the-art M6 TOFSIMS platform and adds a full integrated SPM into the UHV analysis chamber. The SPM is fully featured and allows the operator to choose from all conventional SPM modes such as AFM, MFM, and Kelvin probe. The highly accurate piezo stage allows for autonomous movement between the two sample positions, so that the same sample area is analyzed with both techniques. All operators are pleased to learn that spare cantilevers can be stored and exchanged without breaking vacuum. There are many application areas where the M6 Plus offers unique capabilities, and we will show several examples of these in this video. An inherent limitation of SIMS is that it does not know what topography a sample has, whether this is starting topography or induced topography. In this example, we will only consider the starting topography. If we have a sample where components sit at different heights, when we obtain a two-dimensional SIMS image, everything will appear to be on the same plane. After taking an AFM image at the start of the analysis, we can correct for this starting topography. Now, even a 2D image can now become a 3D image by combining the SIMS image with the AFM data. This can be used on all kinds of samples, such as this coated steel sheet. The situation becomes even more complicated when we perform a SIMS depth profile or 3D image. In this case, we have both initial and sputter-induced topography to consider. By using two AFM measurements, one at the start and another at the end of the SIMS profile, both kinds of topography can be corrected. The in situ combination of the two techniques allows us to guarantee both analyses occur at the same sample position. A real-world example of this is a 3D image analysis of a TFT display. Here you can see the TOFSIMS only data that shows a planar surface. However, after correcting the topography, we can see that there is a large amount of topography both on the surface and within the depths. In fact, if we evaluate the cross-section, we can see that there is more than a micron height difference between areas on the sample that are shown as coplanar in the SIMS-only data. Not only are relative height differences important, but an absolute measure is also important. Typically for sputter craters, this is done using profilometry. The downside to doing this ex situ is that it is sometimes very difficult to find the crater, especially on clear glass samples. We have therefore developed a surface profiler mode for our M6 Plus. There is of course a basic difference of the scan range of a typical SPM and the size of a SIMS sputter crater. To allow us to measure the large craters, we utilized a stitching line scan approach of the AFM. This mode can be measured across millimeters with nanometer resolution. The other big benefit over a traditional stylus profiler is the ability to obtain roughness information. Another advantage of the in situ surface profiler mode of the M6 Plus is that one can perform multiple crater measurements during a SIMS depth profile. This allows for an exact determination of individual layer thicknesses. The example shows a TOFSIMS profile of a BPSG co-implant. The measurement was paused for 4 times to run surface profile scans and measure the exact depth of the sputter crater. This information was later used for a selectual depth calibration of the whole SIMS profile. In summary, the M6 Plus is a unique instrument that combines TOFSIMS with SPM to obtain full 3D characterization of samples as well as direct comparison of chemical and physical properties. We hope you have enjoyed this brief introduction to the M6 Plus and encourage you to check out more videos in this series and go to our webpage at einthoff.com for further information about our full range of surface analysis instruments. My name is Sven Kaiser. Thank you for listening and goodbye.